Okay, in this video I want to go through how to differentiate the function ln x. If you have y equals ln x, then what is dy over dx? Now if you haven't done anything on logarithms yet, I'll just give a very brief introduction. The easiest way to think of the ln x function is to think of it as the inverse of the e to the power x function. So in the same way we have multiplication as the inverse of division and addition as the inverse of subtraction, we say logarithms, or now ln is also called the natural logarithm. We have logarithms as the inverse of raising something to the power. So let's say, just take an example, let's say we have y equals a times b. If I want to find b, I would say y divided by a is equal to b. So I have a multiplication. To find b, I can take the inverse. So the inverse is division, so I say y divided by a is equal to b. In the same way, if I have two numbers, y equals a to the power b, to find b, what we do is we say we take the logarithm of y to the base of a, and it is read as the logarithm of y to base a is equal to b. So here you can see that the inverse of raising something to the power is to take the logarithm. And the natural logarithm, which we write ln, is just the case where this number a is equal to that number I showed in the last video of e to the power x, where it is equal to 2.718, or approximately equal to 2.718, which we called e. So the logarithm of base e of x is written as, it is called the natural logarithm, and it's written as ln of x. So that was just a very brief introduction to what ln x is, but what we are concerned with is how to differentiate this. Now, the derivative of ln x, I'll just write that down as 1 over x. There are different proofs, ways to prove this. I'm not going to go through the proof. I'll just say that if y is equal to ln x, then the derivative of ln x is 1 over x. And now we can use this with the chain rule to do more complex problems involving the ln function. So let's say we have another function. Let's say we have y equals ln 2x plus 5. And let's say we want to differentiate this. And once again, I have a function of a function. I have the ln is one function, but I have 2x plus 5 as the argument of that function. So in this case, I take this bracket here to be t. So use that as my t substitution for the chain rule. So let's say if I take t is equal to 2x plus 5, then y would be equal to ln of t. Then dt over dx will be equal to 2. I get dy over dt is, now the derivative of ln x is 1 over x with respect to x, so the derivative of ln t must be equal to 1 over t. So then I can write down the chain rule, which says dy over dx is equal to dy over dt times dt over dx. So this gives dy over dt, which is equal to 1 over t times dt over dx, which is equal to 2. So this simply gives 2 divided by t, or if I substitute back for t, I get 1 over 2x plus 5 times 2. Or you could write this as 2 over 2x plus 5. Okay, let me take another example. So let's say we have y equals ln of, say, 2x squared plus 3x plus 2. Once again, you take what this function here is. I have ln of some function, so you make that your t substitution to use the chain rule. So let's say t is equal to 2x squared plus 3x plus 2. So I get y equals ln of t, and once again, if I take dt over dx, I would get 4x plus 3, that is differentiating this function here, which gives dy over dt is equal to 1 over t. We've just seen that the derivative of ln t is 1 over t. And if I use the chain rule, I get dy over dx is equal to dy over dt. So that's 1 over t times dt over dx, which is equal to 4x plus 3. And the final step is to substitute back for t. So I get 4x plus 3 divided by t, which is 2x squared plus 3x plus 2. And in the same way that we had a very quick way of doing it for the e to the power x function, or the e to the power fx function, we can also derive something for ln fx, or for the derivative of ln fx. So let's say we have y equals the natural logarithm or ln of the function of some function in x, ln of fx. Okay, in this case what you can do is you can say let t equal to this function fx. T is equal to fx and y will be equal to ln of t, and once again dt over dx, I'll write that as f prime of x because this just means the derivative of fx. Then dy over dt is equal to ln of t, sorry, dy over dt is equal to 1 over t. And by the chain rule, I get dy over dx is equal to 1 over t times dt over dx, which is f dash of x. And substitute back for t, I get 1 over fx times the derivative of fx. Now if you remember, for y equals e to the power fx, the derivative was e to the power fx times f dash of x. Now in this case, if I have y equals ln of some function x, I get 1 over whatever that function is multiplied by the derivative of that function. So let's use this rule and do one quick example. So let's say we have the function y equals ln of 3x cubed plus 6x. So what it says is if I have y equals ln of fx, write down 1 over whatever that function is. So it says dy over dx will be equal to 1 over whatever that function is. So I get 3x cubed plus 6x times the derivative of whatever this function is. So what that is the argument of ln of the ln function. So I get times the derivative of 3x cubed, that will be 9 times x squared, plus the derivative of 6x, which just gives 6. I could rewrite this as 9x squared plus 6 divided by 3x cubed plus 6x.